Let's start by explaining the topic. Well, the true unsung hero of this planet is without a doubt the ozone, which nowadays just seems like the beat up old vet of the game. Well, how does the ozone protect life on Earth from ultraviolet light anyways? That is a great question. Let's embark on this journey of knowledge through the stratosphere. Let's look at Earth with and without the ozone. Here is Earth with an ozone. Here is Earth without the ozone. Ultraviolet rays are able to reach the surface. With an ozone, they are blocked, as the ozone acts as a shield and the world is happy. Without the ozone, or a hole in the ozone, the world basically burns, as all living things are affected and harmed by the radiation caused by these UV rays. And the world is upset. Let's go over some vocab to get a better understanding. Up top, we got ozone, which is a gaseous O3 molecule. Here we have stratosphere, which is the second layer of the atmosphere of the Earth, and it is located above the troposphere and below the mesosphere, about 6.2 to 32 miles above the surface. Lastly, here we got ultraviolet light, or UV light, which we will be using in the future. So these are invisible rays that are part of the energy that comes from the sun. It can cause skin damage, premature aging, melanoma, and other types of skin cancer. It can also cause problems with the eyes and the immune system. Okay, let's continue. Let's take a closer look at Earth without the ozone layer. Zooming in, here we can see the UV rays again as they start to wreak havoc all over the surface. All humans will start to notice a change and be upset by it, but start to scream as the UV rays start wreaking havoc and destroying their body from the inside out. All life forms, including plants, will also start to notice it and will also become upset as they, as well, start dying. Okay, moving on, we have the ozone layer overall, and this is just going to be a general information. The majority of the atmospheric ozone is concentrated in a layer in the stratosphere about 9 to 18 miles below the Earth's surface. Ozone itself is a molecule that contains 3 oxygen atoms. At any given time of the day, ozone molecules are constantly being formed and destroyed in the so-called stratosphere. Over the decades in which it has been measured, the total amount has remained relatively stable. And right here, we will see a diagram showing just where the ozone is. The ozone layer's full-time job is to absorb a portion of the radiation that comes from the sun, preventing it from reaching the planet's surface, and ultimately protecting life on Earth. The most important part of this radiation absorbed is known as ultraviolet light. More specifically, it absorbs a portion of UV light called UVB. Here are all the different UV lights. Coming from the sun are those 3 UV rays. UVC rays are the most damaging but are blocked entirely by the atmosphere. UVB rays are what are the most concerning to us, as when they seep through, they cause all the problems we talked about earlier. UVA rays are also a problem, but not as much, as they can cause cataract and retinal diseases. UVB has been linked to many harmful effects, including skin cancers, cataracts, and harm to some crops and marine life. Life would be a lot different without the protection of the ozone. Let's look at what that looks like right here. Let's cut to a reenactment of what I have been talking about so far.
UVB rays, I command you to go attack the Earth.
Okay. Yes, sir, Sonny.
Who are you guys?
We're the UVB rays.
You cannot come in here.
Fudge! You!
Oh, gosh.
Hey.
Over the past several decades, scientists have established records that detail normal ozone levels during natural cycles. The ozone concentrations in the atmosphere vary naturally with sunspots, seasons, and latitude. Over time, these processes are now well understood and could be predictable. In the past, each natural reduction, emphasis on natural, in ozone levels has been followed by an eventual recovery. Since the 1970s, however, evidence has shown that the ozone shield has been depleted well beyond natural processes, which can be seen in this diagram right here. This is it after the 1970s, and this is it before the 1970s. Depletion of the ozone leads to less protection. Ozone molecules are destroyed when chlorine and bromine atoms come into contact with ozone in the stratosphere. Interestingly, one chlorine atom can destroy over 100,000 ozone molecules before it is removed from the stratosphere. This is why ozone can be destroyed more quickly than it is naturally created. Some compounds release chlorine or bromine when they are exposed to intense UV light in the stratosphere. These compounds contribute to ozone depletion and are called ozone-depleting substances, or ODSs. ODSs that release chlorine includes chlorofluorocarbons, hydrochlorofluorocarbons, carbon tetrachloride, and methyl chlorophyll. ODSs that release bromine include halogens and methyl bromide. Although ODSs are emitted at the Earth's surface, they are eventually carried into the stratosphere in a process that can take as long as 2 to 5 years. As mentioned earlier, since the 1970s, concerns about the effects of ozone-depleting substances on the stratospheric ozone layer prompted several countries, including the United States, to ban the use of chlorofluorocarbons as aerosol propellants. However, global production of chlorofluorocarbons and other ODSs continue to grow rapidly as new uses were found for these chemicals in the following: refrigeration, fire suppression, film insulation, and other applications. Some natural processes, such as large volcanic eruptions, can indirectly affect ozone levels. For example, Mount Pinatubo's 1991 eruption did not increase stratospheric chlorine concentrations, but it did produce large amounts of tiny particles called aerosols, different from consumer products, also known as aerosols. These aerosols increase chlorine's effectiveness at destroying ozone. How the topic is related to Chem 1031? Well, if it is not already evident how this topic relates to chemistry, and specifically this class, well, ozone is actually a colorless gas with the structure of O3 and is found naturally in the environment. We have discussed gases, products, and reactants a lot in class, and they are not unfamiliar terms when talking about ozone. Since I have already mentioned how gas relates, let's look at products and reactants when it comes to the ozone. As mentioned earlier, chlorine is able to disassemble the O3 molecular structure 100,000 times its quantity. It doesn't stop there though. The final point of connection I would like to mention directly is the reaction of ultraviolet light and ozone. The ozone absorbs the UV light and breaks apart into an O2 molecule and a free oxygen atom, such as this.
Increased exposure to ultraviolet radiation has a chain reaction all the way up the food chain. It starts off by affecting plants and microorganisms and eventually killing off the prey. Without the prey, the predator will eventually die off as well. This affects the food chain because one link of the food chain can have a massive destruction of the rest of the food chain.
Let's wrap up. Overall, the ozone is very reactive and attacks other molecules in the air, often regenerating oxygen in the process. This is why ozone is important to us, as it absorbs much of the sun's harmful UVB rays, splitting back into molecular and atomic oxygen. Okay, let's now move on to my final thoughts. Well, chemistry can be seen as harmful or helpful depending on the point of view. Although pollutants have increased the rate of ozone depletion to a point where it can't naturally regenerate, there is still hope if humanity works together. Countries have already begun phasing out some of the harmful chemicals that were discussed earlier in the video. Yet more work must be done.